So the hypotenuse is opposite to the right angle, okay? The hypotenuse is the side, sorry, that we identify based on the position based on the right angle, right? There are two other sides in the triangle, as you can see, side A, B, and BC, and those are also important. But we name those sides according to our angle of reference. So if I put my angle of reference over here, my angle of interest, and let's call this angle theta, right? Which side would be AB and which side is BC? Anybody remembers what they're called? The side opposite to your angle of reference. What is it called?
The side opposite to the angle of reference is called the opposite.
Good. So this is your opposite side. And then the other side is called what?
Adjacent.
Correct. The adjacent, right? So in the right angle triangle, we have three sides because it's a triangle, obviously. And the hypotenuse is the side opposite the right angle. So that's the side AC. And it's also the longest side in the right angle triangle. That hypotenuse is named in relation to the right angle, right? But the other two sides, the opposite and the adjacent, are named or identified according to where the angle of reference is. So, for instance, if I had instead put the angle of reference over here at A, then BC would be the opposite side and AB will be the adjacent, right? So those two sides, those two other sides, named according to or identified according to where the angle of reference is. Anybody recalls what are the three trig ratios that we use? Anybody? The three different trigonometric ratios that we use. Who could recall what they are? Let me see. Josh or Matthias, you're going to tell us? Tell us, Matthias. I saw you unmuted.
This is sine, cosine, and tangent.
That's right. It's sine, right? Which is abbreviated as like SIN, still pronounced sine, cosine, and then tangent. So we say sine, cos, and tan, right? So sine theta, cos theta, and tan theta. The cos of an angle, in this case theta, that's our angle of reference, is equal to something over something. Cos theta is also equal to something over something, and tan theta is equal to something over something. That's why we call them ratios, right? It's the ratio of the sides. Who could tell me what is the ratio for sine?
Is opposite over hypotenuse.
That's right. Sine is opposite over hypotenuse. What about cos? What's the ratio for cos or cosine?
Opposite over, no, adjacent over hypotenuse.
That's right, adjacent over hypotenuse. And then tangent, the last one. What is the ratio for tangent?
Opposite over adjacent.
Excellent, opposite over adjacent. And guys, remember we did this acronym, SOHCAHTOA. So SO is SOH, CA is CAH, and then TOA, tangent, is TOA, right? That's where we got the acronym from. SOHCAHTOA. I mean, it sounds funny, but it does actually help you remember the different ratios, right? And we can use trigonometry to find unknown sides or unknown angles in right angle triangles. So let's just refresh a little bit on how to find an unknown angle when you are given when you're given two sides in a triangle, right? So let's say I have a triangle. I'm trying to be good and draw my triangles with the lines provided here instead of the kind of craziness I've been doing. Right, so let's say we have this right angle triangle here. Another thing is these ratios, sine, cos, and tan, in like sine being opposite over hypotenuse, adjacent over hypotenuse, etc. SOHCAHTOA can only be used for right angle triangles. Okay, so there are different rules that you can use to find missing sides and angles in non-right angle triangles. And actually, it's called the sine rule and the cosine rule. We'll move on to that soon enough. All right, so say we have this triangle. This side is, let's call this side A, this side is B, and this side is C. This is example one we're looking at. And this side is 14 centimeters, and this side CB or BC is 9 centimeters. Well, the first thing that you need to do, and we want to find out what is angle A, right? So find angle A. Whenever you have a question where you need to identify or find a missing side or a missing angle using trigonometry, the first sensible thing to do is to name your sides. All right. It's really important to name your sides correctly. Otherwise, you might end up using the wrong ratio. So if A is our angle of reference, let's identify the sides here. Well, 14 centimeter, you don't need to name that side according to A because what side is 14 centimeters? AC. What is that side of the triangle?
Hypotenuse.
That's right. It's the hypotenuse, right? So we really just need to look at the other side. What would that side be, Matthias? The side BC.
Opposite.
Correct. Good. And now that we've identified the sides that we have, we need to now recall which ratio uses opposite and hypotenuse. Which of the ratios uses opposite and hypotenuse, guys? Anybody knows? Which
Sine.
ratio? Sine. All right. So let's recall that sine of theta is equal to opposite over hypotenuse. So now we we substitute our values in there. So sine of, well, angle A is what we're trying to find, is equal to the opposite side, which is 9 centimeters, over the hypotenuse, which is 14. All right. And now A will be equal to the sine inverse of 9 over 14. So that's what you have to type on your calculator. I don't know if you all recall, but when you have to find an angle, you have to use the inverse function. So you'd have to use sine inverse, cos inverse, or tan inverse if you're looking for the angle. So there are two ways to do it. And I think, Matthias, I think your calculator was doing an interesting thing. So I think you needed to like write 9 over 14 as a decimal first or something. Can't remember. But 9 over 14 as a decimal would be like a long number, 0.642857142. Now, you don't have to write all of those digits, but I would suggest taking at least 4 of them, 4 decimal places, because the closer you round it, well, the less decimal places that you round it off to would be the less accurate your answer. So try to round off at the end of your answer, right? So we have to find sine inverse of 9 over 14. You have to use second function in your calculator, most likely, or shift, depending on if you have a Casio or a Sharp. So you press second function, sine, to get the sine inverse, or shift sine, and you'll get sine inverse. On your calculator, you would literally see sine raised to the power of -1. All right, so you check that of 9 over 14, and your answer should be 40.0. So yeah, 40, right? Degrees. So angle A is 40 degrees. Guys, I want you all to try one for me, right? Just to get the juices flowing again with using trigs. And you could copy this one down. All right, so number 2, let's say we have Good. So we have a right angle triangle here. This one, I'm going to call it PRQ. This is your angle of reference here. And we have this side, 6 centimeters, and then the side here, PQ, as 5 centimeters. And your job is to find angle Q. Everybody try this one for me quickly. Kids aren't here. Right, was that Matthias? Matthias, was it you? That said you got it?
Yeah.
Right. Okay, so tell me, what did you do first?
I label it as a triangle.
Yeah. Okay, so where did you label? Tell me. What's RQ?
Hypotenuse,
Mm-hmm.
and then PQ is adjacent.
Yeah, that's correct. Good. And then what?
Um, Adjacent over hypotenuse is 5/6
But which ratio is that?
cosine.
Yes. So cos of theta is adjacent over hypotenuse. Yeah. Cos of Q it would be what?
5/6.
Mm-hmm. And then what did you get as the answer? So if cos of Q is 5/6, then Q would be the cos inverse of 5/6.
I get 33.55.
Correct. Well, it would be 33. If you're taking it to two decimal places, it will actually be 33.56 because the third decimal place was 7.
Yeah.
Yeah, so you just add 1. Good. Excellent. So 33.56 is the answer. Soraya, did you get that? Where's Soraya?
Miss, I got this 33.9.
33.9. But did you do this exact thing? Cos inverse of 5/6?
No,
What did you do?
I divided 5/6.
Uh-huh. So you did 5/6 and you got 0.833.
Yeah,
Uh-huh. And then you did the cos inverse of that instead.
yeah,
But you should have still gotten sine. I mean, you should have still gotten 33.573. It wouldn't really matter if you did cos inverse of 5/6 or if you did it of 0.8333. You should still get the same thing. Maybe check. Oh, did you just check um Soraya, did you just do cos inverse of 0.83 or 0.83333?
I think that the cos inverse of 0.8.
Just 83. Because when I checked
Yeah,
cos inverse of 0.83, I also got 33.9. Now, generally, it would be the same, right? Like if you round both of our answers up to the nearest whole number, we would still get 34 degrees, right? Because 33.9 and 33.56 will both round off to 34 degrees. However, this is why I told you guys if you're changing it to a decimal first, like if you're gonna do if you're gonna do 5/6 as a decimal, take it to at least 4 decimal places because the more numbers you include, the more digits you include in your calculation before the final answer will be the closer you are, more accurate you are, right? You'll have a higher degree of accuracy. So instead of doing 0.56, sorry, instead of doing 5/6 as 0.83, I would have probably done 0.8333, right? And Soraya, if you check what is cos inverse of 0.8333, it's gonna be 33.56, right? So,
Wow, that's a lot of threes.
what is that, honey?
And I said that's plenty trees.
Yeah, but the more decimal places you include in your calculation before rounding off the final answer, the more accurate your answer will be, right? So, guys, when you're changing, if you're changing this as to a decimal first before finding the cos inverse of it, take as many decimal places as possible. I think 4 is a good enough number of decimal places to take, right? 4 or 5. Good. What about you, Joshua? Did you get this answer?
Yes, please.
Okay. Safira. Wait, I think Safira's mic isn't working today. Oh, Safira isn't even here. Faith, did you get it, honey?
Yes, miss.
Okay, good. Right. I wonder where everybody else is. Hmm. Okay, so let's look at how you find an unknown side. Just let's refresh our memory on how to find an unknown side. Okay, so let's say we have gonna be good and use the lines to draw the triangle. All right, so all right, so we have this right angle triangle here. It's kind of in a weird orientation, but it's still the facts of it still remain the same. It still is a right angle triangle, still has a hypotenuse, and the other different sides of the triangle. Okay, so this triangle, let's say this side is M, and this side is N, and this side is L, and this side is 9 centimeters. And this angle here is 65 degrees. Okay. And I want to find the side MN, right? So I'm going to do this on with you and then I'm going to give you one to do, right? So we're going to find MN. All right. So first things first, guys, you need to identify identify the size that the one that you're given and also the one that you need to find. Those two sides will make up the ratio that you need to use to solve this question. All right. So we have this, if 65 is the angle of reference, it means that this side LM would be your adjacent side. It's adjacent to the angle of reference. And then the side that we want to find, side MN, is the opposite side since it is opposite to your angle of reference. Which ratio, guys, uses opposite and adjacent?
Tan.
That's right. So tangent uses the opposite and adjacent. So we're going to recall that tan theta is equal to opposite over adjacent. All right, and now we substitute our values in there. We will replace theta with our angle of reference, which is 65 degrees. So tan of 65 degrees is equal to the opposite side. That's the side we want to find, side MN, over the adjacent side, which is 9 centimeters. All right, so therefore, MN, you cross multiply here. All right, you could put tan 65 over 1 and then cross multiply. So cross multiplying would mean it'll be 1 times mn, so that would be mn, and then that would be equal to 9 times tan of 65. And you literally just type that in directly on your calculator, 9 tan 65, and you'll get your answer. So the side mn is equal to 19 0.3 centimeters taken to one decimal place, or three significant figures. Is that okay, guys?
Mm-hmm.
All right. Let's look at another one. Let's say I have, yeah, let me use, the only thing I just detest with drawing the triangles, just it takes so long to draw it with the lines, you know? Faye, did you get any coursework in math as yet for the term?
No, we didn't get any coursework or projects or anything.
For math or for all your subjects?
For math.
Okay. What about the rest of you? Soraya, did you get any coursework as yet for the term?
Yes.
Really? In math?
Mm-hmm.
What was it? A test or like a project?
A test. It was on like land tax and discounts and stuff.
How was it?
A little difficult.
Really? Do you need me to go through those things with you, love?
Yeah, maybe.
Okay. All right. If you have the paper, send it to me, okay?
My teacher can give me it back yet, but if she does, I'll send it to you.
Okay, but did you get your marks on it as yet?
Not yet, miss.
Okay. All right. What about you, Joshua? Did you get any coursework as yet?
Yes, please.
What was it, a test or like a take-home
I
assignment?
I have gotten one take-home assignment and two tests.
Okay, and how were they so far?
I had it like I got 29 out of 30 in one of the
Oh,
tests,
good.
and I don't know about the homework assignment as yet.
Okay. But so excellent work. If you have like a take-home assignment, you could send it to me before you submit it, and I could, check it for you,
Okay.
right? And if you have a test coming up too, you can let me know, and I could see, I could probably give you some practice questions. What about you, Matt? Did you have any homework or sorry, not homework, any coursework assignments yet?
No, miss.
Okay, cool. But yeah, guys, keep me in the loop, all right? So I can help you. Right. So in triangle ABC, I want to find the side AC. So first things first, if I want to find AC, we need to identify, well, what side in the triangle that would be. AC is what side, guys?
AC is the hypotenuse.
That's right. AC is the hypotenuse. And then they gave me this other side of 8 centimeters. What side is that, Soraya?
Adjacent.
Nah, it's actually the opposite because the angle of reference here is this angle, 62 degrees. So 8 centimeters, that side 8 centimeters, AB is opposite angle C, so that would make it the opposite side. Which ratio uses the opposite and hypotenuse?
10.
Yes. So we'll recall that sine of an angle theta is equal to the opposite over the hypotenuse. And now let's substitute our values in there. Well, sine of theta in this case is 62 degrees. So sine of 62 degrees is equal to the opposite side, which is 8 centimeters, over the hypotenuse, which is side AC that we are trying to find. All right, guys, I always like to just put this over 1 and cross multiply. I just find that to be an effective method. So I'll say AC times sine of 40, sorry, AC times the sine of 62, right? So AC times that is equal to 1 times 8, which is 8. And therefore, if AC multiplied by sine of 62 is 8, then AC will be equal to 8 divided by sine of 62. So that would be, you type it in exactly like that on your calculator, 8 divided by sine of 62. which is 9.06. 9.06 centimeters taken to two decimal places, or in this case, three significant figures. Right? So if you notice in this one, right now it's all algebra, and I would actually prefer if you just learn how to solve different types of algebraic expression, how to solve algebraic equations, regardless of if a is or x, your unknown, is in the numerator or the denominator, right? But you can also just memorize certain things too, right? So, for instance, when you are finding a side and the unknown side is in the numerator, right, of the ratio. So like here, how mn, the side that we're trying to find, is on top, is the opposite side. Then I would multiply the known side by the tan of the by the sine, tan, or cos of the angle, right? However, when the unknown side is in the denominator, you divide the known side by the sine, cos, or tan of the angle. Some people remember it like that. I think the safest way to go about things is to just really understand the algebra behind it, because once you do that, you will always be able to work it out, right? Because this is just an algebraic equation. Anything to do with solving for an unknown is an algebraic equation, right? So that's one way to look at it. So I'm gonna give you guys two to look at to find the unknown side. Okay, I'm gonna do that now. Let me just pause the recording.
I was a little bit confused. We
All right.
we were supposed to find the opposite.
Yeah, YZ would be the opposite side. Yeah.
So it would have been like the hypotenuse on the opposite range.
Yeah, correct. So which ratio is that?
So that one is 10.
Opposites and hypotenuse. What is
Oh,
it,
sorry.
honey?
It is 10.
Yeah. So sine theta is opposite over hypotenuse. Yeah. And then what? What is the next step?
So I have sine with 41 degrees
Mm-hmm.
equals to 9.2
Mm-hmm.
over x
Well, that's the problem.
yz.
Well, it would actually be YZ over 9.2 because the opposite side is YZ. So then you're gonna replace the opposite with YZ in the formula, and the hypotenuse is 9.2. Do you see it now?
Yep. Yes, please.
Good. So then it would be YZ times 1 is YZ is equal to 9.2 times sine of 41. Did you end up doing that? So though 9.2 times sine of 41?
Yes, please.
Okay. What did you get?
I had got 60.
9.2 times sine of 41. I got 6.0.
Oh,
Are you sure that's not what you saw?
I forgot the point.
Yeah, good. So it'll be 6, yeah? 6.04 centimeters if we take it to two decimal places. Good. Faith, are you ready with this other question?
Yes, miss.
All right, so tell me.
So we know that the hypotenuse is ln
Hmm.
and the opposite is 12 centimeters.
Yeah.
So that's sine.
Okay. I didn't realize I gave you two with sine. Okay, so sine theta is opposite over hypotenuse, yeah?
So then it'll be sine 31 degrees over
Mhm.
1. And then we cross multiply by 12 over ln.
That's right. So 12 is the opposite side, ln is your hypotenuse that we're trying to find. Good, and then we cross multiply. So ln times sine of 31 is equal to
12.
And then what?
You divide 12 by
Uh-huh.
sine 31.
Perfect. So that would be what?
That is 23.29 or 23.3.
Yes, 23.3 is correct. Even if it was to two decimal places, it'll still be 23.30 because it's 299. So that 9 would round it up. So 23.3 centimeters to one decimal place here. Okay, excellent. Good job, guys. Let's take a short break.